So you're ready to make your conclusion, and we're going to stop talking about your sample now. That's what we were talking about before, all the way through the analysis. That was your sample. Now we're going to talk about what do we think is happening in the population. Now that's why this is called making the call, because it is a bit of a guess, but the idea is that it's a guess that is made on evidence. Okay, so let's look at how much evidence we really need in order to claim that one group is maybe getting slightly higher scores and whatever it is than the other. So here we go. So we started by asking a question like, which is longer, carrots or potatoes? Or do Labour voters tend to be younger than National voters and so on? So what we're going to do is, obviously we're not going to go and find every single person over 18 in Selwyn. That would take too long. Take a sample. Now hopefully that sample will represent the population. It'll just have people from Southbridge, it'll have people from Rolleston, have a few people from Lincoln, maybe even somebody from Taitapu, okay? So it's going to be a big group of people, well spread through the whole population, and we're going to find out their age and their voting preferences and so forth, hopefully. Okay, so we're going to look at the sample, we're going to describe the sample first, that's our analysis. Now we're on to saying, okay, well, can I answer the question? Do I see enough difference between the two groups in my sample to claim that they're actually different in the population? Okay, so remember this. You're looking at a sample and you're trying to make a decision about the population. Okay, is it not just in the sample, but actually true in general? Yeah. And if you took another sample, you would get slightly different results. So what we're looking for is a big difference. So how big is big enough? Okay, let's have a look. So you can claim that there's a difference between your two groups if either median in your sample is outside the box for the other sample. So let's have a look at an example here. So looking at that first one there, that median is inside the other box. This median's inside the other box. So neither one is outside. Now remember, if the median's outside the box, you can make that call. You can make that call. If the median's outside the box, you can make that call. If a median's outside the box, you don't need both. You don't need both. If a median's outside the box, you can make that call. Okay, so if either median is outside the box, yeah? Okay, so in this case, neither is, so we cannot. Both medians are inside the box, so I cannot claim that the median of B is greater than the median of A. Now notice there is a shift there. They've both gone the same way. So we'll talk about shift in the population, and we'll say in the sample B tended to have bigger scores, but we can't say that, you know, that's going to be true in general. That was just our sample, right? Now in the second one, kind of in a way even more clear, because what we notice is, okay, yeah, both medians are in the box, and so therefore we can't make the call, and I cannot claim that the median of B is greater than the median of A. In fact, I can't even say that there's a shift in the sample, because look, the two ends of the box are going different ways. So no shift in the samples, and there's not enough evidence for a difference in the population. Okay, looking at this one here, what do we notice? Well, that there's one median that's inside the box, but remember, you don't need both. So looking at this, it's outside the box. We can make the call. As the median of B is outside the box for A, I can claim that the median of A is greater than the median of B in the population, whatever the population is. So is it Selwyn, is it carrots on the farm, or whatever. Okay. So let's have a look at this one. Okay, just a quick illustration. Total overlap. So there's no shift, and neither sample shows a tendency to have higher scores. So there's not a big enough difference. There's not really a big difference between these two boxes, right? What happens if we move B over a bit, eh? Yeah, that'll be a good place to put it. So now we are seeing shift. B is shifted right. Okay. So we can say that B's sample shows a tendency to have higher scores, but because those medians are both inside the other box, we can't claim there's a big enough difference between the samples to claim a difference in population. What if we shift B over a bit more? Right, now, what do you notice? Now there's a big difference in our samples. Okay, and the difference between our samples is so big, we think, hang on, this isn't just happening from chance, right? This is just a bit suspicious to be happening from chance. It must be that in the population, B has a higher mean. Now, that's an educated guess. It's based on that big difference that we see in our sample. But the odds are that there's actually a difference. So we're going to make that claim. We're going to make the call. You know, we're making the best decision we can in the circumstance. Okay, so actually, it looks like that other median is outside as well, isn't it? So pretty strong evidence there. Okay, so what are we saying? B is shifted right. Yep, we noticed that. B sample shows a tendency to have higher scores, definitely. And in fact, that tendency is so big, there's now a big enough difference to claim that B tends to have higher scores in the population because we see those medians outside the box. One way that we can say this is we could say that this 3/4 of B, 3/4 of our sample from B is above the median for A. Yeah, so 3/4, 75% of our sample, and remember our sample's over 30, or it should be, is over the halfway line. That's quite a lot to have over the median just from chance. So I think there's a difference in the population. I hope that helped.